Awesome. So I think we have a few more people trickling in, but we'll go ahead and get started today. I'll start off, like all sessions, with the forward-looking statement. So it's important we show the slide to mention this presentation is for informational purposes only, and it may contain forward-looking statements as we continue to develop this product for the future. And let's start off with a couple of introductions. I'm Peter Pogorski. I'm a product manager on the Ingestion team at Databricks. And I'll be joined by Bret, an engineer on the Ingestion team, and he'll be showcasing a super exciting demo using one of our database connectors today. And in our session, we're going to discuss the managed connectors that anyone can use to incrementally ingest data from popular database sources such as SQL Server, Postgres, and MySQL. We'll start off by setting some context around Lakeflow, and then we'll deep dive into the database connectors. From there, we'll demo the product, discuss the roadmap, and then share some of the best practices for database ingestion using Lakeflow Connect. So let's start off with some critical context. Lakeflow is our unified data engineering solution for ingestion, transformation, and orchestration. It's essentially our vision for what data engineering should be in the evolving world of data and AI. And what makes Lakeflow so great? To start off, Lakeflow will provide an end-to-end experience across all of those steps. So it really simplifies the ETL stack on Databricks. It's also easy to use for those who want that simple point-and-click offering, while also being high-powered for users who are fluent in things like PySpark or have needs like sub-second streaming. And finally, it's going to produce reliable, fresh, and accurate data that downstream users can trust. For example, Lakeflow has integrated and proactive quality monitoring and alerting. And in terms of the actual products, there's three key pillars that make up Lakeflow. The first being Lakeflow Connect, which is for ingestion. The second being Lakeflow Declarative Pipelines, which are for transformation. And then finally, Lakeflow Jobs for orchestration. And today we're going to dive into Lakeflow Connect, specifically focusing on the database connectors. But first, why did we actually build Lakeflow Connect? You likely have a lot of different databases. This might include SQL Server, Postgres, MySQL, maybe an Oracle database or two. And it can be really difficult to get that data into your lakehouse so that you can actually do meaningful things with it. To start, database ingestion is hard to ramp up on. For example, every database is going to have its own protocol, authentication method, metadata API, and even within the same database, this behavior can vary quite significantly across the different database versions. And then change data capture mechanisms, they're going to be different across every single database. Some support logical replication, others use transaction logs, change tracking, or maybe even triggers. And many database APIs are often undocumented, unstable, or they're not very performant. And source databases can have proprietary or extended data types that are hard to map cleanly to targets like Parquet or JSON. And running CDC and snapshot queries can affect the production performance of the source database. So CDC ingestion really needs to kind of strike a balance between throughput versus the impact on the source. And then moreover, once you've actually set up your connector, you're going to need to maintain it. So how are you going to handle schema evolution? How are you going to actually monitor both the pipeline health and the data quality that's coming in? And how are you going to actually recover if the database or the extraction infrastructure actually goes down? And then when you take that and multiply it across all of your different database sources, you're going to have a lot of complexity. So it's no wonder that organizations spend a lot of time not only building, but also maintaining their ingestion pipeline. And given all this complexity, that work often lands on a specialized data engineer who has a bunch of other important things to do. But in spite of all of that, you might not want to even democratize that data. because you have a patchwork of different pipelines, which are very hard to govern effectively. For example, across all those users, who's actually tracking lineage to make sure we're not duplicating all of the tables? Or who's implementing data governance and best practices on these pipelines? And then we also want to make sure that nobody's blowing up the company's data engineering bill, and that everyone's actually respecting data retention and PII policies. So at the end of the day, it's hard to get the full value from your data. You're probably running into pipeline outages, and you might even have some security risks with that data. So that's why we built Lakeflow Connect. In short, Lakeflow Connect aims to solve these challenges by enabling simple and efficient data ingestion into your lakehouse. And there are three key things that we're most excited about. The first is the simplicity and ease of use. You can set up a production-ready pipeline in just a few steps. And once you've set a connector up, it's also fully managed with schema evolution, observability, alerts, automated retries, and even more. So this is going to lower your overall maintenance costs, but more generally, it's going to mean you can spend less time moving data and more time actually getting value from that data within the lakehouse. And Lakeflow Connect is also unified with your existing tools and governance. For example, the pipelines and the tables you ingest are governed by Unity Catalog, and it's all orchestrated via Lakeflow jobs. Finally, Lakeflow Connect is efficient, with incremental reads and writes wherever possible. And moreover, since ingestion is just the first step, we actually write the data to support incremental processing downstream as it works its way through the medallion architecture. And along the way, it has a simple, cost-efficient pricing model that's simply based on the compute which is used by your pipeline. So what sources are actually supported with Lakeflow Connect? Over the past year, we've been focusing on expanding out our connector breadth, and we now have 14 connectors across various release states. And 8 of those connectors are now generally available. And then in addition to our native CDC connectors, we're also announcing a new set of connectors for databases and data warehouses, which are going to enable you to ingest data without making any source modification, such as having to enable CDC or creating a replication slot on the database. With these connectors, we're able to incrementally ingest data by leveraging a primary key and a cursor column. And if these columns aren't available on a table, we're still able to ingest the data, but we'll just do so using a batch-based method. And these connectors will be coming very soon, and will support all of the sources which are currently available via Lakehouse Federation. So that's a high-level overview of Lakeflow Connect. Let's now lift the hood on these connectors. We'll start off by talking about the architecture of a database connector. Each database connector has the following components. The first is going to be a connection, which is a Unity Catalog securable object that stores authentication details for the database. The second component is an ingestion gateway. So this is going to be a pipeline that takes metadata, snapshots, and changelogs from the database. And it's going to stage them in a Unity Catalog volume, either backed by S3 or ADLS. And the gateway runs on classic compute in order to simplify the network connectivity to your privately secured database. And it will run continuously to keep up with the log retention on the source database. We then have an ingestion pipeline, which picks up the data that was staged in Unity Catalog and applies the changes into the destination tables. This pipeline runs on serverless compute and can be scheduled to run with whatever custom schedule you want. And finally, the destination tables, where the ingestion pipeline is actually writing the data, these are going to be streaming tables, which are Delta tables with extra support for incremental data processing. And now you might wonder how we actually establish that connection to your source. For cloud databases, we can connect via private link, or if a workspace has a peered VNet or VPC, we can deploy the gateway right inside of it. And then for on-prem databases, we're able to connect to your database directly from your workspace using services like ExpressRoute, Direct Connect, or a VPN. And with Lakeflow Connect, we're able to offer efficient data extraction through some key capabilities. First, we've optimized native CDC for each specific data source. So this means we can capture changes while minimizing the overall impact to your system performance. Second, we offer flexible ingestion options so that you can start extracting data immediately, so without any complex source setup being required. And this combination means that you can begin seeing value from your data in minutes and not weeks, while maintaining the reliability and efficiency that your business demands. Second, Lakeflow Connect is built for speed while being efficient through intelligent parallelization. We run multiple parallel processes, both between tables and within individual tables, reducing your initial data load times. But we don't stop there. We're also going to parallelize your ongoing CDC loads alongside historical snapshots, so you don't have to wait for one to finish before the other starts. And finally, one of the biggest pain points with data replication is handling failures and restarts. Lakeflow Connect will eliminate this headache with automatic checkpointing. If your connection drops or you have a process which fails, you don't have to start over from scratch. Our connectors resume both CDC streams and snapshot operations from the last successful checkpoint, saving you hours or even days of reprocessing time. And this built-in resilience means your data pipelines are truly enterprise-ready by recovering gracefully and keeping your data flowing. So I'm now going to hand it over to Bret to demo one of our database connectors.
All right, thank you. Check, check. Okay, good. Hi, everyone. As Peter mentioned, my name is Bret Grantham. I am a developer and the subject matter expert for SQL Server at Databricks, and I have the privilege of working on Lakeflow Connect. I'm based out of Los Angeles now, but I grew up in southern Louisiana. And living in California, you are spoiled for choice with 24 professional sports teams. But back in Louisiana, there was only one team that mattered. Well, there's a basketball team now, but whatever. The fan loyalty there is just absolutely legendary. So today we'll be working with that Louisiana team that for the purposes of this demo, we'll call the Crescent City Crusaders. Okay, this team is terrible, folks. Look at last year's record, 5-12. That's laughingstock territory. The fans wear paper bags over their heads at the games. That's true. This team's in trouble, and with their salary cap issues, it's not going to come, and the help's not going to come in the form of better players. Enter Bayou Analytics. I love that logo. Let's look at their mission statement. Empowering the Crescent City Crusaders to achieve championship excellence through innovative data analytics and actionable insights that drive strategic decisions on and off the field. Powerful stuff. Okay. Meet Drew Boudreau. Drew's not doing so well, and that's because he is a huge fan of the Crescent City Crusaders, and they're terrible. Also, he has exported 47,000 CSV files manually this year, and he's got more database connections and social connections. I hear he's even been seen down on Bourbon Street on weeknights. He's a mess. But luckily, there is hope for Drew, because he has recently learned that Databricks now supports ingestion from SQL Server databases. So after trying and failing with other products, could this finally be the answer? Okay, so this is my demo video. In this video, we'll follow Drew from his own 1-yard line where his data is trapped in SQL Server to the end zone with clean Delta tables and Unity Catalog. We'll watch him drive down the field by setting up his ingestion gateway, configuring continuous ingestion from the bioanalytics database on Azure to our staging volume, avoiding fumbles with proper change tracking, and scoring a touchdown with a complete pipeline. So let's head over to Azure Studio and take a look at the data in our bioanalytics database. Okay, here we are in our Azure database, our bioanalytics database. We have 4 tables, kickers, quarterbacks, offensive linemen, and wide receivers. First, our kickers table. Yeah, this tracks our special teams roster, a small specialized group that's critical to game outcomes. With only 5 players, roster changes here are infrequent but impactful. Each signing decision affects our salary cap and field goal reliability. Next, we have our quarterbacks table. This table manages our most expensive, most valuable position group. We track contract details, salary cap implications, and player descriptions for our quarterback depth chart. These are moderate frequency updates driven by injuries, performance, and contract restructures. And next we'll see our offensive lineman table, and just like an offensive lineman, it is much larger than kickers and quarterbacks. This table captures our offensive line performance data, tracking blocking assignments, pressures allowed, and grades for our 5 starting linemen plus backups. With 2,000 performance records, this represents substantial game-by-game analysis that helps our coaches evaluate performance and protection schemes. And finally, our highest volume data set with 12,000 records, the wide receivers table. The wide receivers table is the widest table we have. This table captures the most granular receiver analytics. We track every target route, reception, and performance metric across practices, games, and training sessions. Wide receivers have the most diverse skill sets and situations to analyze, generating extensive data for our offensive coordinators to optimize play calling and personnel packages. Okay, so those are our tables, and before we set them up for ingestion, let's understand our options. SQL Server offers 2 mechanisms for tracking data changes. One is called change tracking, and that is the more lightweight process. It just tracks whether a column has changed, gives you the latest state. CDC, on the other hand, change data capture, is a little heavier process, but it captures all of the before images and after images of all your data. So this is good for if you need complete audit history with your tracking, or if you just need synchronization, that's for CT. So we'll go ahead and set up this necessary CT and CDC configurations on our tables. And I'll walk you through this process step by step. First, we're going to enable CT with the first command. That's going to enable it for the whole database, and we'll enable it with a reasonable retention period. This configures our database to retain change tracking information for 3 days with automatic cleanup to prevent excessive storage use. And our kickers and quarterbacks table are perfect for change tracking because they have primary keys, and we just need to know what changed, so we don't need the history. So let's enable CT on our kickers table and our quarterbacks table. All right, and now for CDC, let's enable CDC on the database level. This command activates the CDC framework for our entire database, creating the required system tables and capture and cleanup jobs. Our offensive linemen and wide receivers tables are ideal for CDC. They have no primary or unique keys, and we need the complete change history. So we'll enable CDC on our offensive lineman table and our wide receivers table. All right, so now we just have one more step before the bioanalytics database is fully set up for ingestion, we need to install the necessary DDL support objects in the database. These objects allow Lakeflow Connect to keep track of schema changes. This is a one-time setup step, and Databricks provides a convenient setup script for this purpose. And we'll go to the Databricks documentation site, which Drew has so cleverly bookmarked, and download the script. Now we're going to run this script against our bioanalytics database in just a moment. Okay, so first we need to provide some information in the script. That'll be up, there we go. You'll see options for CT, CDC, both, and none. None will remove the objects from the database. We're going to use both since we're using CT and CDC, and we'll also supply our username here. Supplying the username directs the script to enable the privileges for using these objects. These objects for CT are a trigger and a tracking table, and for CDC, there's a few stored procedures for managing capture instances. And that's it. That's we're set up for ingestion. So now that our source is prepared for ingestion, we'll head over to the Databricks web UI, and we'll select New, Add or Upload Data. Here we'll select SQL Server. We'll create our ingestion gateway. I'll call it Bayou Gateway. We'll select this location for our staging data. I'll pick my catalog, and I'll create a schema. We'll call it Crusaders, and we'll leave a nice little descriptive comment so no one is confused about which Crusaders we're talking about. And, all right, and now we'll go to the next step and set up our pipeline, which will read from staging and write to the Delta tables. We'll call it Bayou Pipeline. We can see our destination catalog there. We'll create a connection to our source database, Bayou connection, copy in our host domain URL. There's our username, bioanalytics user, our super secret password, and port 1433 for SQL Server. We'll click Create Connection. Here you can see it already selected. We'll click Create Pipeline and Continue. Okay, here in step 3, we'll select the tables we want to ingest. So in about 8 seconds, we'll be doing that. Or, yeah.
We're just fetching all the schema and metadata.
So here we see our source database and our schema. We'll just select the whole schema. And we hit Next. Select our Crusader schema for the destination, and now we'll click Create Pipeline. Okay, so we will head to our 5th and final step. We have just to set some settings, some optional settings. There we go. So you can create a schedule that will schedule the applier pipeline to read from staging and write to your Delta tables. I'm just going to leave the default of to read and write every hour. You can also add an alert. I'm just going to leave the default of the current user to receive failure messages, and we'll click Save Pipeline and Continue. Here we go. All right. Now that is it, and it is spinning up. And so we'll just give it a moment to come up. But while that's starting, I'll talk briefly about our schema change tracking. If the schema change is additive, like you've added a column, we will require a full refresh of the table. But if it is not additive, say you drop a column, we'll just keep on trucking. No refresh required. You will see the value stop getting updated, but you'll keep the historical data. So, all right, initializing. Oh, you can pick any time, right? Anything. Yeah.
Yeah, it could be seconds, it could be hours, minutes, days, or you could use table triggers.
Okay, so here are our tables. You can see a nice little graphical representation. We can drill down into the tables. We'll take a look at the offensive lineman table. Here you can see the data coming in. We'll go back to all tables. And we'll see that our data has arrived. If you look under upserted records, you see all our rows there. And we'll go to our catalog just for sanity's sake and make sure all the data's there. So here's our catalog. There's our schema, Crusaders. Here you can see our tables. And I've also created a query that we're going to run just to be doubly sure all our data's there. So we're connected to our catalog. Now we'll connect to the Crusaders schema. Untick that. Okay. Kickers. There's our kickers. And our QBs. So far, so good. All 2,000 rows of our offensive lineman performance data. And 12,000 rows for our wide receivers. And there you go. So and finally, I'll show you where to find the pipeline logs. Just let it show you the rows there. All right. So logging. That's the last thing I want to cover here. We'll go to jobs and pipelines. There we go. Here you can see our pipelines here. We can look at recent runs of the pipeline. We'll dig in here. And we can view any issues. We'll click View Issues, and you can get to the event log. View Issues, Event Log. And here we can see any informational messages, warnings, or errors. And if you need to drill down deeper, you can actually go to the compute logs here. And you can see standard error, standard out, log4j logs. And with that, we have reached the end zone. And that's what we call a touchdown. Yeah, look how happy he is now. I don't know about that green drink. I think that must have came from Bourbon Street. But thank you very much. And with that, I'll talk about some more SQL Server connector. Let's see, with our SQL Server connector, we provide support for most SQL Server environments running SQL Server 2012 and above. This includes Azure SQL, Amazon RDS, SQL Server on-prem, and SQL Server on VMs. We also provide support for all SQL Server data types, including some of the more complex ones like geometry, SQL variant, and XML. We provide the ability to select between CDC and CT, and we will optimize the selection based on table properties if both are enabled on a table. Okay, in addition to the features that are available today, we will be adding support for auto refresh when table cleanups occur. This could be because of some schema evolution operation or truncate or some automated cleanup. We can automatically refresh. We're We're also going to be greatly simplifying the setup of the native of CDC on the source database. You saw the process we went through. It was just a few steps, but we're going to make it even easier. We're going to automate it on our platform. So, and finally, we're also going to expand the authentication options in addition to username and password and Microsoft Entra ID RBAC, which are available today, by adding support for Microsoft Entra ID service principal-based authentication. And with that, I'll hand it back over to Peter to talk about some other database connectors. Thank you.
Awesome. Thank you, Bret. I really hope the Crescent City Crusaders do better now that you have their SQL Server data in the Lakehouse.
Thank you.
And I'm very quickly just going to go through some of our other upcoming connectors. So let's start off with the PostgreSQL connector, which is now available in private preview. If you do want to participate in the Postgres connector preview, reach out to your account team and we can get you onboarded. And with our Postgres connector, we're going to support all major variations of Postgres. This is going to include RDS, Aurora, and Azure Postgres. And our connector is built natively on PG output, which means you're not going to need to install any third-party library on your database. And we focus on robustness. So we're going to provide full support for toast columns. We're going to support partition tables and the automatic handling of schema changes. We're also going to include replication slot management. And looking ahead, we're looking to support replication from read replicas on databases running Postgres 17 and above. And we all know that with Postgres, the replication slots that are critical for change data capture, if left unmanaged, they can fill up and they can bring the entire database down. So traditionally, teams have to manually create and monitor those replication slots, which is pretty operationally expensive. And with Lakeflow Connect, we've automated that entire lifecycle. So slots are going to be created as needed and then safely cleaned up. So we're going to reduce your risk of an outage and simplify the ingestion operation altogether. And lastly, on Postgres, schema changes are very difficult to replicate because in the Postgres write-ahead log, there's no tracking of schema changes like alter table. So a lot of CDC solutions will either miss them or require manual handling anytime a schema change happens. And this is going to create a lot of fragility when the source schema evolves. With Lakeflow, we're going to handle all of those schema changes automatically, whether it's a column being added, modified, or removed. So your pipelines are going to stay up to date without any manual intervention. And it's fully automated and built to support dynamic, real-world environments. And finally, we'll talk about our MySQL connector, which will be entering private preview later this year. Our MySQL connector is going to be built directly on the native binlog format, meaning that no third-party libraries are required once again. It's going to support change data capture from both the primary and the replica instance. And it includes the full handling of binary data types. And most importantly, it's also automatically going to adapt to schema changes, like the column additions or the type modifications. So once again, no manual intervention is needed. And now all of these connectors are powered by a simple, efficient, and entirely compute-based pricing model. You're simply going to pay for the compute that's needed to run your pipelines. And pipelines for SaaS sources like Salesforce and Workday, they're going to run exclusively on serverless infrastructure, and they're just going to incur serverless DBU charges. For database sources like SQL Server, the ingestion pipeline is going to run on serverless. However, the ingestion gateway could run on classic compute or serverless, depending on the source. So for database connectors, you may receive a combination of classic and serverless DLT DBU charges. So that wraps up our chat about database connectors. If there's one thing to take away, it's that we're offering simple, unified, and efficient connectors that are intended for any data practitioner. To learn more, you can visit our product page, or please reach out to your account team to participate in some of our previews or provide suggestions for our product. And with that, Bret and I will be up at the front to take some questions. But thanks, everyone, for joining.